All right, in this lesson, we're going to be looking specifically at how we now use the unit circle to find those trig exact values. And this particular lesson is going to walk you through the exact kind of problems that you're going to see on the quiz. So in each set, you're going to see 3 problems. And if you think you know how to do them already, I'd really encourage you to pause and get your answers before you listen to my explanation. All right, so let's jump right in. And we're not going to have a unit circle in front of us when we do this because when you take a test or a quiz or the AP exam, there won't be one sitting right in front of you. So we're going to start off with our very first problem here, which is the cosine of pi over 2. And the key here is just to think, okay, where's pi over 2? I remember I start here. Oh yeah, pi over 2 was halfway to pi. I'm right here. Cosine is the x-coordinate, and so that's going to be 0. Now you can be doing this on paper or you can just be visualizing this in your head, but this is how you would do this. So sine of pi over 6. Okay, so I'm going to draw my quick circle, and it doesn't actually matter how, well, that's pretty bad, but we'll show how even an inaccurate one can be helpful. So pi over 6, remember, here's 0, and here's pi. Pi over 6 is 1/6 of pi. So I pretty quickly see, oh yeah, it's going to be this one. That's 1/6 of this. And I need this point, and I know sine is the y-coordinate. And I always remember, one of these is 1/2, the other is √3 over 2. So I look at my y-coordinate, and I say, am I halfway up, or am I like that √3 over 2 almost all the way up to 1? Which is what, 0.866. And I see, oh yeah, I'm about halfway up. So there we go. And sine of pi over 6 is 1/2. Tangent of pi over 4. I remember pi over 4, that's 1/4 of the way to pi, so that's going to be right here. And this is that one where I just know √2 over 2, √2 over 2. Tan is y over x. Well, if I have the same thing on top and bottom, that just reduces to 1. And we've got our first set done. All right, let's try another 3. If you think you know how to do them, please pause and try them first. All right, here we go. Sine of 5 pi over 6. So I'm saying to myself, 5/6 of the way to pi. Here's pi. I go 5/6 of the way. I end up right here. Sine is my y, and my y goes up. I can see, oh yeah, I'm going halfway up. Y equals 1/2. So this is 1/2. All right, cosine of negative pi over 4. So for negative pi over 4, I am going around this way in the opposite direction, 1/4 of the way to pi, but since it's negative, I'm going in the opposite direction. I recall that this was √2 over 2, √2 over 2. When I reflect over the x-axis, my y-coordinate turns negative, though that really doesn't matter here because cosine is my x-coordinate, so my answer is √2 over 2. All right, let's try the tangent of pi. Oh, we all know where pi is. It's right here. So I say, okay, tangent is y over x. My point is -1, 0. So that's 0 over -1, and 0 divided by anything is 0. So my answer is 0. All right, we have another set of 3. Again, I encourage you to pause this before I work through them, and you can check your answers. So tangent of 4 pi over 3. When I'm thinking 4 pi over 3, it doesn't hurt to think of it as a mixed fraction. So 4/3 is 1 and 1/3, so I've got 1 pi, and another third of the way takes me down here. So 1 and 1/3 pi, and I need both coordinates. So this is one where we're going to reflect up here and up here to pi over 3. Remember, 4 pi over 3 is going to be a reflection of pi over 3, and that is halfway over and up √3 over 2. Now when I reflect back this way, my x becomes negative, and when I reflect down here, my y is also negative. So now I've got -1/2 and negative √3 over 2. So to do this, I need y over x. So I've got negative √3 over 2 over -1/2. And this is going to simplify. The negatives are going to cancel. And I'm dividing by 2 on top and bottom. So when I multiply by the reciprocal here, I end up with simply √3. All right, let's try sine of 2 pi over 3. So I go around and let's see, I'm going 2/3 of the way to pi in the opposite direction. And wait a sec. Oh, that's the exact same place as right here. Sine is my y coordinate. So I've got negative root 3 over 2. All right, let's try cosine. 11 pi over 6. 11 pi over 6, boy, that's really close to 12 pi over 6, and 12 pi over 6 is 2 pi. So that's going to be almost all the way around. Or I can think of it as a mixed fraction, 1 and 5/6 pi. So I do 1 pi and then 5/6, and I end up right here. So there's 11 pi over 6, which is a reflection of this one, which is pi over 6. And we know that that's root 3 over 2 over. It goes up 1/2. When I come down here, my y becomes negative, but that doesn't really matter because cosine is my x coordinate. And I get root 3 over 2. All right, we're going to have one more set of these. At this point, you really should pause and try these before I go over them. All right, here we go. Cosine of 7 pi. Boy, we're going to go around 7 pi times. Let's think about that. So I'm going to change colors so we can see what's happening. So here we go. I've gone around 2 pi, go around again, 4 pi, go around again, 6 pi, and 7 pi lands me right here. All right, so this is at negative 1, 0. Cosine is my x-coordinate, so I got negative 1. Let's go back to blue. All right, sine of 5 pi over 4. We should be thinking of it being 1 and 1/4 pi. Puts us right here. Remember over here, we reflect over and down. This was root 2 over 2, root 2 over 2. They're both going to be negative over here in the third quadrant. Negative root 2 over 2, negative root 2 over 2. And sine is our y coordinate. All right, and our last one in this set is the tangent of 2 pi over 3. So if 2/3 of the way to pi, so 2/3 of the way to pi is right here. This reflects back to this one, which is 1/2 root 3 over 2. So when we come back over here, we're at negative 1/2 root 3 over 2. And we're going to divide y over x. So root 3 over 2 over negative 1/2. And this simplifies to negative root 3. All right, so we're done working in that direction. Now we're going to work in the opposite direction. We're going to be looking at inverse trig values, which really we're going to use the exact same tool. We're just going to be working backwards. So if we look under here, you'll recall when you were in pre-calculus, when you had inverse sine with the -1 or arc sine, one of them meant you had a restricted domain and the other meant all solutions. For our purposes in calculus, we're not going to differentiate between the two. In both cases, we're going to be working with a restricted domain, and it's going to be a function with exactly one answer. And that answer is going to be the answer to the question, what is theta if sine theta equals 1/2? So that's how we're going to be thinking about it in terms of the unit circle. So first, let's just review our graphs and see how that restricted domain works out. So I'm going to take a look here and start with sine x, and let's just look at one of these at a time. So if we look at sine x, it's a function, but if we take a horizontal line test, we'll notice that the inverse will not be a function. So we have to restrict the domain so the inverse is a function, and we end up restricting it to this portion right here. And that's what's graphed over here. And you'll notice when we're on the inverse, our x values, negative pi over 2 and pi over 2, became our y values, negative pi over 2 to pi over 2. And our y values, negative 1 to 1, became our x values. So our input was the output here, and our input over here became the output over here. All right, so what's really important for us, though, to recognize is that on the unit circle, what we just graphed was from negative pi over 2 to pi over 2. And so that is the portion we're going to be looking at on the unit circle when we're looking for answers. So, and our answers would always be between there we go, negative pi over 2 and pi over 2. All right. Also, it's good to notice that if we put in a positive value here, we get a first quadrant answer. And if we've got a negative value, it's a fourth quadrant answer with a negative angle. All right, let's see how this looks for the others. So now let's go to cosine. When we restrict the domain on cosine, we would then actually, we can't do the same portion like this because, well, that doesn't pass the horizontal line test. So let's get rid of that. What we would actually do is take this portion like this. And so you can see that if we look over here, same thing, our y values, -1 to 1, became our x values. And now our x values from 0 to pi became our y values. But you'll notice we went from 0 to pi. So that means all our answers for inverse cosine are going to go between 0 and pi. We'll just mark that on this graph. So our answers will be between 0 and pi. All right, so our last one, tangent. Tangent looks a little different than the others, but it's the same idea. Again, wouldn't pass the horizontal line test, so we restrict it to just this portion right there, and the x's and y switch again, and we'll notice that this goes from negative pi over 2 to pi over 2, and so just like with sine, we're restricted to negative pi over 2 to pi over 2. Now, this seems like a lot to remember. I'm going to give you the real short version of it. Basically, if there's an answer in the first quadrant, that's your answer. And if you don't have an answer in the first quadrant, it's going to be the quadrant adjacent to the first quadrant. Notice it's never an answer in the third quadrant. So it's either in the fourth or the second, and it'll never happen where you have a choice in both. All right, so let's try this out now. So here we are, our very first problem, inverse sine of 1. So it helps us to really make sure we understand what we're doing here. Inverse sine of 1 means that, okay, sine of theta equals 1. And if we remember that sine is our y coordinate, we're really saying we're looking for where y equals 1. So we draw our unit circle, and oh, well, y only equals 1 right there, and that's at pi over 2. There's our first answer. Let's try another one. For this one, we're looking to see when sine of theta equals 1/2, which we're really asking, when does the y-coordinate equal 1/2? So I grab my unit circle, and I'm going to say, okay, y equals 1/2. Well, y equals 1/2 along there. Now, I see two answers, but remember, if I ever have an answer in the first quadrant, that's always the one I want. And this is at pi over 6, or 1/6 of the way to pi. Let's try the same thing with cosine. Cosine of theta equals 1/2. Cosine is my x-coordinate, so x equals 1/2. So I take my unit circle, I draw my circle, and I'm saying, okay, oh, x equals 1/2 here. So I draw this. Oh, I have a first quadrant answer. If I have a first quadrant answer, I always take it. Pi over 3. You'll also notice if I have an answer that's positive in my input on these, then my output is in the first quadrant. All right, let's try some more. Now these are all arctangent or inverse tangent problems because arctangent's a little different. It's not just a y-coordinate or an x-coordinate. So it really helps to rewrite this as an arctan, and since I know my unit circle, I know I'm going to want this to be root 3 over 2 over 1/2, because I know if I simplify this fraction, I get root 3 over 2. And so now I know that this is my y, and this is my x. So I'm looking for where on the unit circle, and see my x coordinate's 1/2, so I go over 1/2 and up root 3 over 2, there it is. So 1/2 root 3 over 2, and that happens at pi over 3. So there's my answer. Okay, let's try this next one. Inverse tan. Now, I did some experimenting with this, and you can always put the negative on top. So I write this fraction, negative root 3 over 2 over 1/2. And remember, this is y, and this is x. And this will get us in that correct quadrant, because let me just go back here. When we were looking at tangent before, remember, if we're not positive, we're in the fourth quadrant. If we're in the fourth quadrant, that means y is negative. So since tangent is y over x, if we have a negative in here, the top has to be our negative one. And so we are now still going over positive 1/2 down to negative root 3 over 2. And so this is going to be negative pi over 3 equals negative pi over 3. Now, when we've got negative root 3 over 3, that's a little trickier to split into a fraction. So it first helps to unrationalize the denominator. So this is the arctan of negative 1 over root 3, which equals the arctan of, we're going to keep the negative on top, negative 1/2 over root 3 over 2. And remember, this is x, and this is y. And since I'm running out of room, I'm going to go to the circle up here. Looks rather square, doesn't it? All right, so x is root 3 over 2. So I'm going all the way over here, and I'm going down negative 1/2. And there it is, pi over 6. So that's going to be pi over 6, because I went over root 3 over 2 and down 1/2. All right, so now that you've seen a few of these, I really encourage you to pause and try this next set before I go over them. Welcome back. Thank you for pausing. All right, let's take this first one, and we're going to say, okay, sine of theta equals 0. That means I want my y-coordinate to equal 0. So I look at my unit circle, y equals 0 along here. Oh yeah, I definitely want this one. That's going to be at 0. All right, remember this out here is, we always want the one right by the first quadrant. All right, inverse cosine of negative root 3 over 2 means I want cosine of theta to be negative root 3 over 2, which means I want my x-coordinate to be negative root 3 over 2. So we take our circle and x. So here's x. Ooh, negative root 3 over 2, way over here. So I'm going up and down like this. And remember, I never want the third quadrant. So this is the one I'm going to want. And that looks like it's 5/6 of the way to pi, because that's that one that comes in like that. So we get 5 pi over 6. All right. And then we have arctan of negative 1. Now remember, with arctan, we're always rewriting this as a fraction. Well, to get 1, I've got to have the same thing on top and bottom. And we'll remember that it's at root 2 over 2 is where we have the same x and y coordinates. So that's what we want. We're going to put the negative on top, because that's what we're always going to do with our arctan to get us in that fourth quadrant. And so we can see that, oh yeah, I'm going to be going to this point right here in the fourth quadrant, which is negative pi over 4, because that has an x-coordinate of root 2 over 2 and a y-coordinate of negative root 2 over 2. All right, we've got one last set that you can try on your own and then listen to the explanations for. Let's sine of theta equals negative root 3 over 2. That means y is negative root 3 over 2. Take a look at my circle. I want a y that's down here, almost all the way to 1. I don't want the third quadrant. I want this one. And let's see, if I was up here, it'd be pi over 3. So down here, it's negative pi over 3. Inverse cosine of negative 1 means cosine of theta equals negative 1, which means I want an x-coordinate of negative 1. The x-coordinate is only negative 1 one time, way over here at pi. All right. And lastly, inverse tangent of root 3 over 3. So that's the one where we say inverse tan. Well, that's the same thing as 1 over root 3. I want to rewrite this as the inverse tan of 1/2 over root 3 halves. And then I say, okay, I want to go over on my unit circle. Let's see, this is my x. So over root 3 over 2, up 1/2, because this is my y, and I land at pi over 6. All right, I hope this has been really helpful as you get ready for your exact values quiz.